In this video, we're going to talk about the derivative product rule, our product rule for finding the derivative of a product. So again, we see if u and v are differentiable functions of x, then their product, u times v, u of x times v of x, what that's going to be equal is u, the first, times the derivative of the second with respect to x, plus v times the derivative of the first u with respect to x. All right, so we have lots of different ways we can write this. I like to say that d dx of u times v, actually I'll throw some color in here, we've got u times v. So that is the same as u v prime, prime meaning derivative, plus v u prime. U times the derivative of v plus v times the derivative of u. Again, these are just variables. We're just using u and v to illustrate that there is a first and a second. So another way I could have written this would have been d dx. I could say first times second. And so I think this sometimes helps us to think about it. I remember the definition as first times the derivative of the second plus the second times the derivative of the first. Or you could think about it as d dx. You could use a and z, first and second. And that would be a derivative of z plus z derivative of a. So you see the pattern, and that's the point of me changing the variables here, is for you to see that there's a pattern. I mean, we could use symbols if we wanted, and I could say d dx of smiley face times heart. And that pattern would then become smiley face, derivative of the heart, plus the heart, times the derivative of the smiley face. All right, so when we want to take the derivative of two variables or two variable expressions that are multiplied, we can use the product rule. So let's do some examples illustrating the product rule. In this example, we're going to find the derivative of a product. So the function is f of x equals 2x squared plus 5 times the quantity 10x minus x to the fourth. So, in this situation, you say, Ms. Stein, why don't I just FOIL that and use my power rule? And you can do that. I'll show you that when I'm done. But in this situation, we just want to make sure we understand how to use the product rule, because eventually there are situations where we must use the product rule. So here I have a first and a second. I'll use F and S. You could call it U and V, A and Z, whatever works for you. So at this point, I'm going to calculate my derivative, and I'm going to write out what I'm doing. So my derivative, F prime of x, that is equal to the first 2x squared plus 5 times, I use a square bracket, just a personal preference to indicate I'm going to take the derivative. So times the derivative of the second, which is 10x minus x to the fourth, plus the second, 10x minus x to the fourth, times the derivative with respect to x of 2x squared plus 5. All right, so I've listed this out. I haven't taken any derivatives yet. Those parentheses are purely associative. But I've written first times the derivative of the second, first times the derivative of the second, plus second times the derivative of the first. So I have two small derivatives I need to calculate. And as I mentioned while I was working through it, I use the square brackets. That's just a personal preference. when I'm teaching. So the square brackets mean I'm still going to take the derivative. The parentheses, I don't need to do anything with that. And it's just a way to help keep track of what I'm doing. So f prime of x, we have 2x squared plus 5. Now, the derivative of 10x minus x to the fourth, using the power rule on both of those, that would be 10 minus 4x cubed. And then we have plus 10x minus x to the fourth, and this derivative would become 4x. The derivative of 2x squared is 4x, the derivative of 5 is 0. All right, so we're done. We've taken the derivative. At this point, we would just want to FOIL. So I'm going to FOIL this out. That is 20x squared plus 50 minus 8x to the fifth minus 20x cubed. And distributing that 4x to both of those terms, I have plus 40x squared minus 4x to the fifth. And we have several x to the fifth and x squared terms, so we can combine those together. F prime of x equals, I have negative 12 x to the fifth minus 20 x cubed plus 60x squared plus 50. And, you know, in the effort to always factor our GCF if possible, f prime of x equals, I can pull a factor of negative 2 out. So negative 2 would leave me with 6x to the fifth. Pulling negative 2 out, that's plus 10x cubed minus 30x squared minus 25. So this represents my derivative. This line, the second to the last line here, this is perfectly acceptable as your derivative. But as we move forward, you know, we're always trying to reduce things when possible and canceling common factors. So we always look to factor a GCF out if we can. All right? Now, as I said at the beginning, you don't have to use the product rule here. I could have FOILed this at the onset, right? So let's look at what that would have given us if I'd FOILed it and then taken the derivative. So I'll go back down to the bottom. And again, I'm going to start with what we had. So our original function, no prime, f of x is 2x squared plus 5 times the quantity 10x minus x to the fourth. So without using calculus, if I had applied algebra first, I could FOIL this and I would get 20x cubed plus 50x minus 2x to the sixth minus 5x to the fourth. And so in this situation, if I apply my derivative just using a power rule, f prime of x would give us 60x squared plus 50 minus 12x to the fifth and minus 20x cubed. And what you should notice is that what we've found here, this is exactly the same, right? We have all the same terms. Negative 12x to the fifth, negative 20x cubed, positive 60x squared, and positive 50. And so I'm sure you're saying, Ms. Stein, why do I need to use the product rule? Well, as we move forward, there are situations where you cannot multiply things out. So as we learn more rules, this product rule, being able to take the derivative of a product, it's going to be important for us to do it this way. All right, so obviously if I was given this problem, I would have FOILed it first and then just used my power rule. But the product rule is really what will help us once we know the chain rule and we understand derivatives of trig functions as well as derivative of our transcendental functions with logs and exponentials. All right? So let's just do one more example in this video of using the product rule. Here we're going to find the derivative of the function f of x equals 2x plus 5 times the quantity 3x squared minus x. So looking at this, we're being asked to find the derivative, and we notice the operation between these two quantities is multiplication. So that means we would use our product rule. So if I start writing this out, f prime of x, the derivative f prime of x equals the first 2x plus 5 times the derivative with respect to x of 3x squared minus x plus 3x squared minus x times the derivative with respect to x of 2x plus 5. So now I have two small derivatives after I've applied my product rule that I'm going to need to find. So I've got 2x plus 5. Taking the derivative here, the first term I get 6x, and the second term I have minus 1. So that gives me 6x minus 1 plus 3x squared minus x. And my second term, taking the derivative, that's a 2. The derivative of 2x is 2. The derivative of 5 is 0. So I'm left with a 2. And then, of course, we just collect like terms, factor out a GCF if possible. So that is 12x squared plus 30x minus 2x minus 5 plus 6x squared minus 2x. And combining those like terms, I have 12 plus 6, that is 18x squared. 30, take away 2, that's take away 4. 30 minus 4 is 26. And then I have a constant minus 5. So this represents my derivative found using the product rule. So thinking about testing on this, I don't generally put a question this basic about just find the derivative using the product rule, because why wouldn't you multiply it out and use the power rule, right? But the product rule shows up hidden inside other problems, so it's really important for us to know how we use it.